So our first one is a vocab. If a segment, or say blank is a segment whose endpoints are on the circle, what do we call a segment whose endpoints are on the circle? Chord. I like that. Let's do that. A blank is a chord that passes through the center. Who can raise their hand and tell me? Jim. It's a diameter. Okay, a blank is a segment whose endpoints are the center of the circle and on the circle. Ashley? Radius. A blank is a line that intersects a circle at 2 points. Cam? Secant. Yep, secant. And then our next one, Jim. A blank is a line in a plane that intersects a circle at exactly 1 point. Tangent. Okay, in my other class, kids were getting those two confused. When they got those two confused, what they were wondering is which one had 2 points and which one had 1. I don't have a really good way to tell you that. Secant has 2, and if you look at the beginning of secant, it looks like second, and second means second, right? So I think that might be a decent way to remember if you forgot. I'm going to scroll up. Our next part is matching. So match the part of the circle that best describes it. You have CD. What is CD? So CD is a line, is a secant. Hits twice, so secant is D. We have G. What is G? It's the point of tangency, which is F. We have A, which is the center, C. We have CD, which is, yep, so that one's the chord. And then we have E, 10. So hold on, sorry, EB. Thank you. Which one's that one? And AE, which is? So which is B. Thank you all. So, one which is, you're going to name the coordinate for this. There are many correct answers for this portion. So name the point of tangency. Technically, you could have a bunch of places that are going to have tangent lines. I went with the one that's directly shown on here. You see your circle right here. You see there's a tangent line drawn. So I went with this portion right here. So you go over 1, 2, 3, up 1, 2, 3, 4. 3, 4. Again, there are many different ways to put the endpoints of a radius. The first one's going to be the same for both of us. That's the center of the circle. So that's 1, 2, 3, 1, 2. So 3, 2. And then there are 4 convenient radius or radii for us. This one is pretty convenient. This one here is pretty convenient. This one here is pretty convenient. And this one's here is pretty convenient. For the sake of time, you could have any of those 4. I'm just going to do this one because it's on the axes. So we go over 1, 2, 3, up 0, 3, 0. Again, you could have a different answer, but that's the one I did for this radius right here. Next one, name the endpoints of the diameter. Again, you can have a diameter as long as it goes to the center. You can have many of these. For it to be convenient, I either choose the one that makes that T. So I'm going to keep the same endpoint from my radius, which is that 3, 0. And now I'm going to count this one as my diameter. Again, this does not have to be the one you chose. This is the one I chose. So 3, 0. And so my other point here is 3. I count up 3, 4. Okay, endpoints of a chord that is not the diameter. Again, you can create your own chord. I went with the one that was given in our picture. So I went with this one I'm highlighting in red. So my endpoints here are going to be 3, 0. If I can zoom to the right spot. 3, 0. And then I also have 1, 2. And then the center of my circle is over 3, up 2, 3, 2. So we're on cherry pie. You're going to look at BC. BC goes right through the center. What do we call that? It's the diameter. We have ED. It's a segment, endpoints on the circle. We call that a chord. We have AC. From the center to the edge, ends on it. We call that the radius. It's going to be the radius because it starts at the center. Radius. And A is the center. Okay, our next portion. If I write here, can you guys in the back see it, or do you want me to scroll up? I'll scroll up. Okay, so our first one. There are at least two answers for this one. Which one of these is a chord? So MN as a segment is indeed a chord, but it has to be as a segment. So MN. Put the line on top to represent the segment. You could have also picked SK. That would be another good choice. We have the tangent line. Which one of these is a tangent line? Tangent line hits just once. Cam?
QR.
So QR works for me. QR. You could have also named it QT, TS, TR. Or not TS. TQ. Sorry. And then we have the radius. We have two radii here. What are they? Yep, CL, CP.
When is this test?
It's going to be Monday. And then we have a secant line. What's our secant line? MN. Line, arrows on the outside tell you it's a line. Goes straight through, intersects 2 times. And then we have the diameter, which is LCP, but we only named it with 2 points. So it's going to have to be LP. So it's the endpoints, L and P, that we use. And then we have a point of tangency, which is T. So center of D, we go over 1, 2, 3, 4, 5, up 1, 2, 3, 4. Do you guys get 5, 4? Okay.
Wait, I thought you said it was rise over run.
Oh, I thought you meant about slope. Thought we were talking about slope. It's XY. You have point C. You go over 1, 2, 3, 4, 5, up 2, 5, 2. Okay, name the coordinates of the point of tangency for both circles. So the point where you're going to have a tangent line drawn that's tangent to both circles, you're close. It's going to be where those 2 circles overlap. So both the circles overlap at this point. That's the only place you can draw a tangent line to both of them. So you're at 1, 2, 3, 4, 5, 0. So what is the length of circle C's radius? It has a radius of 2. And that means the diameter of C has to be 4. Yep. Because remember, radius is 2 times the diameter is 2 times the radius. And then we have the radius of circle D, 1, 2, 3, which means my diameter is 6. Okay, page 2. We want to find the radius. So what do we have to use? These are right triangles. That means we're using... That's great. I love that. So, yep, it's a squared plus b squared equals c squared, where c squared is your hypotenuse. So we end up with r squared plus 40 squared equals 50 squared. R squared plus 40 squared is what? 1600, yep. 50 squared. Subtract over our 1600. You get 900. R squared equals 900. Square root both sides. 30, yep. So we talked about Pythagorean triples before. Pythagorean triples are where A, B, and C are all whole numbers. This is a Pythagorean triple. It's a 30, 40, 50 triangle. So our next one is 2. You have, again, your hypotenuse, which is 17 squared equals r squared plus 15 squared. What is 17 squared? 289 equals r squared plus 15 squared it is. Subtract over our 225. Thank you. So we have 64 equals r squared. Square root of that, what'd you get, Randall? 8. Our next one, we have our hypotenuse, which is 10 squared across from the right angle, so it's the 10. Legs of r squared and plus 8 squared. It's going to be 100 equals r squared plus, subtract over 64. You get 36 equals r squared. And here I did it for us. Square root both sides. That gives us 6. You have a point where you have two tangent lines or two tangent segments to the same circle. That means that these two are going to be, they're going to be congruent, which means that first one has to be 5. So you know x has to equal 5 because they're congruent. Our second one here, you see that you have to have those congruent as well. You have 13 equals x plus 7. Subtract over your 7. You guys told me it's 6. Next one up. Exactly right. Divide by 2. X equals 9. I guess I could just write it down here.
Looks like the only easy thing.
The radius of a pool, well, let's start here. A child is standing at point B 2 feet from the edge of a wading pool. The distance from point B to point A is 4 feet. If the radius of the pool is 4 feet, is AB tangent to the circle? How do we test this? Yeah, so it's AB tangent to the circle. So the way we would be able to tell this is a problem you guys did in your homework. Should have done it in your homework. So what do you do? Math.
Yeah, what do you say?
Okay, so this is you test it by the Pythagorean Theorem. And if it's equal, you know that it is tangent. So we have, did you say something, hon? Right. We have the radius of r, which is one leg. We have another leg that is 4. So you have r squared plus 4 squared equals, and then you have your whole hypotenuse. This is the part where you plug in your 4 here. 4 plus 2 is 6. We know what our r is. I didn't have to write it as an r. What's our r? It tells us it's going to be 4, as it says it right here. So you end up with 16 plus 16 equals 36. What's 16 plus 16?
32.
32, which is not equal to 36. So no, it is not tangent.
Did you say 6?
Yeah, it's a 6. Second one. So now you know it's not tangent. You have to find the radius if AB forms a tangent. So if we wanted it to be tangent, we'd have to write that out. So we're going to leave it in terms of r. So you have a radius r plus my other leg, which is 4, equals, and then this is the part we did that problem on 2 days ago, where you have part of the radius, and then we have the radius, and then you have the part that's outside of there. How do we find the total length? You add them together. So you have r plus 2 squared. Okay, so r plus 2 is where you're going to do that double distributive property. You have r squared plus 16. I'm going to change my color. X times x, you told me is? Yep, 2x. Oh, let's go here. 2x plus 4. So that is your double distributive property. You combine your like terms. 2x plus 2x is going to give you that 4x. So, yes, ma'am? Because it's a squared. Yep, because it's a binomial that's squared. So we have to make sure we distribute it to.
X squared plus 2x plus 2x.
Yep, it's x squared because x times x is x squared. X times 2 is 2x. 2 times x is 2x, and 2 times 2 is 4.
I remember that from algebra last
It makes me happy. It really, really does. Just so you know. Okay, so it says x, guys. I apologize. Those are supposed to be r's. I do apologize.
It's okay.
It's r. Yep. R, 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 R.
Where?
All the x's should be r's.
Whoa.
There we go.
What is going on?
I just did it in terms of x, and it should have been in terms of r. Okay, so what you're going to do is subtract your r's to the other side. They cancel out. You end up with 16 equals 4r plus 4. You're going to do what with that 4? Yep, subtract it over. That gives me 12 equals 4r. Divide by 4, and I think I heard Mike say it. What'd you say? R equals 3. So your radius would have to be 3. Sorry about that. Our next one is to decide whether the segment is best described as a chord, secant, tangent, or radius. AD. So it is a chord, but it's a specific type. AD goes through our center, so that means it's a diameter. We have EG. EG right here. It's a tangent line. Yep, tangent. It does say tangent. We have CD right here. Radius. And what is the next one? So HB, it's a chord.
Oh, wait. Wait. Okay, I see.
Okay.
K would be.
JK, if it was a line, would be secant. Yep. Exactly right. Okay. Do you need me to go back? Okay. So we are now here. Name the coordinates of the center of the circle. So where, I know this one's faded. Where is the center of this circle? It's hard to see. I had it as 4, 4. 1, 2, 3.
It is 4, 4.
Okay, so I have 4, 4 here. You know that B is just one more over in the X column, so that's going to be 5, 4. Name a point of tangency for both circles. So where do both circles overlap? Right here. So if this is 4, 4, 5, 6, 7, 8, up. What do we have it at 4? 8, 4. What is the length of the radius of circle A? So A is here. We know it's 1, 2, 3, 4. So we have 4. What's your diameter? 8. Because 2 times the radius. What is the radius of circle B? 3. So your diameter is? Okay. Point. Away from the circle that you have 2 lines that are tangent to the circle, which means they are congruent. So we set them equal to each other. Nemo's already solved this one. Yep, divide by 3, you get 8. Next one up, you have 25 equals 2x plus 3. Subtract over the 3. 22 equals 2x. Divide by 2. What'd you get, Mike? 11. And then over here, you have x plus 12 equals 4x plus 9. Subtract over an x. Subtract over 9. Yep, you get 3 equals 3x. Divide by 3. You get 1. So what you are doing, we still have 5 minutes, guys, is that we want to find the measure of the arc indicated. And then identify what type of arc it is. QRS. What type of arc? Is that major or minor? It's major. How do we find the measure? Exactly right. Subtract it from 360. You're fine.
So it's going to stay sideways?
I can't switch it. We're going to stay sideways. Okay. So our next one, we have XY. XY, is it major or minor?
Minor.
So it's minor. What's the measure? So the measure of XY is 25. Our next portion here is we want to find the arc length. Do you guys remember our arc length formula from yesterday? So arc length equals the measure of AB all over 360 times 2 pi r. So that's your formula that we're using for arc length. So over here,
Which number is this?
we are number 3. You have 140 over 360 times 2 pi r. My r is 5. This is the formula, hun. That's the formula I gave you yesterday. That's just the formula. And then I use that formula for all 4 of these. Okay, so when you put that into your calculator, I'm going to need somebody to do that.
I got a calculator. You just want it to the hundreds, right?
Yes.
2.44.
2 point what?
44.
44. Do you guys agree?
Yes.
Okay, I'm going to trust you on that. Inches. Over here, we're doing the same thing. What is your, let's start here. How much of the circle is on this half? It's half of the circle, right? So 360 divided by 2 is 180. So your arc length is 180 over 360 times 2 pi r. My r is half of my diameter, so that's going to be 7. So 7 goes there. This goes into this 2 times. The 2's cancel. What is 7 pi?
7 pi. What do we call it?
21.98 meters. Okay, we have 2 minutes. Let's see if we can get it done. You have 60 over 360 times 2 pi r, which is 4 feet. 60 goes into 360 6 times. 2 goes into that 3 times. 2 goes into 2 1 time. You end up with 4 pi over 3. How much is that? 12.56 feet. And our last one, we have 170.
Wait.
Yes. Are you just double checking it?
It's 9:42. I thought you said 4:03.
You said 942?
Yeah.
Yeah, because I canceled it. 942. No decimal place.
Okay.
Like that, Kaylin?
9.42.
9.42. Okay, sorry.
Confused.
Okay, which part are you confused on?
The
You
number.
don't have time to be confused. We gotta go. Come on.
The number. Y'all saying 3 different numbers.
Okay, and our last one. Ooh, I'm going back. I know, guys. I apologize for that. So that is 170 divided by 360 times 2 pi r. Your r is 10. When you put that in your calculator, what do you get? What is it? 0.47. Really?
I hope so.
When you put in your calculator, it's 170 divided by 360.
Times 2 times pi times 10.
I'm outside.
Okay, so we're going to go with your guys' answers that you provided. Double check.